kick it off by just getting into the basics of the technology. So 3D LiDAR documentation, and then into a little bit of drone documentation before I hand it off to Sean, who's going to talk about using the data. So 3D laser scanning, I think everybody's pretty familiar. It's not all that new of a technology at this point, but everybody's pretty familiar with the digital tape measure that's sending out laser emitted pulse and then recording the time it takes to get back to the device. And we're going to call this a single point measurement. So the scanning device that we show here in the video is essentially using that same technology. But this is the device here. It's about the size of a shoebox, sits on a tripod, and it's emitting 2 million of those single point measurements every single second. And so anything that you can see from the scanning device is being recorded as an XYZ coordinate in space. And that mirror that you see spinning in the middle of the device, that's what it uses to capture everything in the vertical axis. And so it kind of strategically goes through and maps out a single point cloud from a single scan. Now, when we talk about traditional as-built-in versus laser scanning and some of the newer technology that we're using, I always like to use this example that it's kind of like going into a building with a flashlight versus going into a building with a floodlight. A laser scanner really just kind of illuminates a space and paints a picture that you can't truly get from traditional as-built-in with tape measures and a team in the field. So these are the specs behind the laser scanning device that we use. Conveniently enough, UW-M and TechRender, we're on the same platform, which is the FARO laser scanning platform. But the important thing to note, between all of these specs here is that it's survey-grade accuracy in the laser scanning world. So there's a number of different laser scanning platforms. Leica has a number of laser scanning devices. Trimble has some scanning devices, and then FARO as well. But point being, with each scan, you get a scan point cloud, and as you move through a space, you paint a different picture of whatever it is that you're scanning. So in the example that we have on the screen here is scanning a vehicle. So you can see that 4 different scans gives you 4 different point clouds, all with different coverage of the vehicle there. But so long as you maintain what we like to say 30% overlap is kind of that magic number, the software can then do a good job of registering those individual scans together to get to that registered point cloud. So a registered point cloud is a term that we'll continue to use throughout the slides, but really all that means is that post-processing has occurred and all of those individual setups have been tied together. So whether you're applying that to scanning a car or a monument or a building, it's essentially the same process. Whereas I always like to say, if you can see it, you can scan it. And so then conveniently enough, we have a video fly-through of the space that we're sitting in today, Hillside Theater, where you can kind of see a registered point cloud. So all the scan positions have been tied together, and you're able to kind of manipulate the point cloud. So the goal being you create a digital replica that you're able to get into computer models and manipulate and understand and analyze in the best way possible. So this kind of starts to touch on, very quickly after post-processing, you're able to start cutting different sections and elevation views of your point cloud to truly look at a space. And then you also get panoramic images from everywhere that a scan was taken. And the nice thing about panoramic images is they're pretty intuitive for navigating, but then all of the 3D data is embedded in that image, so you're able to do measurements and truly look at a space, both in the 3D view that you can see with the fly-through, but then also a more simplistic image interface. So a number of ways to kind of get into and experience the data, but right out of the field, a very powerful tool, but definitely not a magic tool. There are some limitations with laser scanning. Mirrors, ambient light, reflections, anything that might project an image that the scanner may think something is there when it's not there. So all stuff that can be kind of cleaned up in post-processing. And then in the exterior environment, some of the limitations are weather, vegetation, movement, an active work site. So if you're doing laser scans outside, it's inevitable that you're picking up points on vegetation that shows up in one position in one scan and another position in another scan. So again, that requires just more cleanup and post-processing. But the final sort of challenge that I want to touch on is line of sight data capture. Just the inherent nature of how laser scanning works can be a limitation. So if you are kind of having to collect data that is vertically limited, so if you need roof data and you don't have the opportunity to get on an adjacent building, a parking structure that's nearby to kind of get that line of sight that you need, simply how the scanning device works can be a limitation, which brings us to some of the other tools that we use to mitigate those limitations, being drone photogrammetry, so 3D photogrammetry from drone-mounted cameras. And so this technology produces a somewhat similar deliverable, but different degrees of accuracy, and then it shines in ways that laser scanning doesn't. So the way that this technology works, photogrammetry's been around for quite some time, but thousands of photos, hundreds or thousands of photos, different angles and perspectives of an object can all be tied together. The metadata is embedded in each of the images, so you're recording, the different pitch and roll, the kind of generic GPS location, or if you have a drone that has the survey capabilities on it, a more precise survey location, GPS location. But all that metadata allows you to then tie the images together to get you a 3D textured mesh or a point cloud. So this exhibit here kind of shows that workflow. And then in the end, you're left with a photorealistic object of whatever it is you're documenting. And so that just looks kind of like an image of the AT&T lantern, which I'm sure some of you have walked through the architecture building at UWM. You've seen some of those models. But that photorealistic mesh is the drone data and not a photo image. So this is the former malt plant in West Milwaukee, which has since gone under some demolition, but I think a week before we were able to mobilize 2 drones for about an hour each, so 2 hours of flight time, and you're able to record an immense amount of data in that photorealistic interface. So kind of a more robust version of Google Earth, but this is a screen recording of a web interface. So through a hyperlink, you can kind of send this around, throw it in an email, and for some early planning, some early schematic design kind of really gets you a long way in terms of 2 hours worth of field work time. So really another great tool, which you can see isn't limited to the vertical interface that a terrestrial scanner on a tripod would definitely have some limitations. So that's some drone data, and then I'll kind of get into the workflow. So inevitably, a lot of people's questions is how much does scanning cost? And really what it comes down to is what the number of scans, both the number of scans dictating how much time you're spending in the field collecting those scans, and then how many scans you are tying together in post-processing. So the makeup of the square footage that you're documenting is oftentimes a dictator of that factor of time. So we'll kind of use this building as an example where the first floor is made up of a multi-room scenario, a lot of offices, a lot of blocked line of sight, requiring a lot of scans. So we have this number of 52 scans. Every doorway, you need that overlap, so every doorway, inside every room. A lot of rooms requires a lot of scans, which can drive up the time on site. But then if we jump up to the second floor, and you can see a lot more open spaces, a lot better line of sight to maintain that 30% overlap between scans, you're only at 35 scans. So kind of the nature of the square footage that you're documenting oftentimes dictates how long you're on site. And then for exterior scanning, may seem a little bit counterintuitive, but again, because of the good line of sight that you have, only 13 scans to get around the perimeter of this building. So exterior scanning can kind of be a quicker process than really going through and getting every square inch of the interior of a building. And then again, like I had mentioned, line of sight limitations for this building would require a drone mobilization if that was a critical part. So I know this slide says 200 to 300 drone images. It would probably be closer to 500 to 700, which isn't a huge difference in the time on site. Drone data acquisition is very fast. So that's kind of what we're doing out when we're mobilizing for that first step of field work. And then we get into the discussion about post-processing. So post-processing, again, is tying all the data that you have together into usable data. It's important to know that it's not always required to jump into step 2. It's not always required to post-process the data you have. A lot of times it is valuable simply to know that you mobilized on site, you collected the data, and you have a snapshot in time kind of recorded if you need to jump back to it. So if you have a project that's spanning months to a year on site and you're mobilizing multiple scans, documentation, you don't always have to post-process every single round of documentation. If something critical were to come up, if there were some disputes to be had, maybe you could then jump to that post-processing step. But one thing I will say is that for archival purposes, so a lot, in the world that we talk about historic preservation, one key aspect of post-processing is getting your files to a point where they'll live in perpetuity and they can be used 6, 7, 10 years down the line. So the different scanning platforms do a good job of keeping all their files proprietary to their software. So they make it very difficult to process FARO scans in Leica software, Leica scans in FARO software, and so on. So jumping to that post-processing for archival purposes is usually a pretty good idea. And so we have listed here some file types that we kind of see as an archival standard. So E57s have been around as long as point clouds have been around. And so for the most part, if a software can handle point clouds, it can import an E57. So it's always nice to kind of get to that and export your registered point cloud in that file format so that it can live on a hard drive and it can live as an archival source. Photogrammetry is somewhat similar, but at the end of the day, because the data that you're capturing with photogrammetry are photo files, there isn't a ton that has changed with that over time. So JPEGs, raw images, those will probably live and be useful for a little bit longer than, again, some of those proprietary scan files. But for photogrammetry mesh, which you can also get point clouds from the photogrammetry process, in which case it would be your E57s, your XYZ files, otherwise OBJ and STL are pretty standardized 3D mesh files, which I know some of the later discussions around object scanning will probably dive into a little bit more. But this is kind of where I'm getting to the point where I'll be handing it off to Sean to talk about client deliverables, but that's what we have identified as step 3 in the documentation workflow. So what you're doing with the files and with those sort of digital versions of the real world, I guess, is the more important and interesting part of the presentation. So like I had mentioned, point clouds themselves are inherently useful, where you can cut elevations and sections and you have digitized versions of buildings, objects, but the way in which those can be used is also a large discussion. And so anything from 3D printing to object reproduction, terracotta reproduction if you're doing handheld laser scanning as opposed to terrestrial scanning, but even just fundraising tools, printing out objects for fundraising purposes and getting people excited about projects. So it really is a tool and just depends on how you use it. So I think at this point I'm going to hand it over to Sean to kind of get into the intricacies of some of those deliverables.
All right, thank you, Vince. With deliverables and with this technology and what you can do with it, I guess it really kind of tends to come down to, there's a gentleman I follow on that LinkedIn thing. His name is Hollis Childers. I believe that's the last name. And he always starts with your needs. So what are your needs? Whether it's the needs of how you work as a firm, how you work in an office, or what your client is looking for. If you're, a prospective client, what are you trying to do? What is your project? How does this technology work for you and the such? But because the options are very daunting. There's a lot of them. There's a lot of different levels of expense and a lot of different levels of execution. You get up at the high level and then some things that are a little bit lower, but depending on what your needs are, you can work those to your advantage in a number of different ways. I love the FARO scanner. The beauty of it is it's that degree of accuracy. When you're doing things like a lot of these historic preservation projects, you really want to have a lot of a very high degree of accuracy with these things. So many details, so many historic elements that you need to place just right as you're working through these tax credit projects. And then there's always things too that inevitably are just kind of hidden as you're crawling through one of these old buildings and you're trying to do documentation. It's so difficult to try to actually capture all of these things. Whereas if you're on site with one of these devices, it comes down to one visit. Now that one visit may take you 2 weeks. It may be, you think back to a project like this. This is similar to a project that I was included upon, and it was 2 teams, 2 scanners, and it took us 2 weeks. So it's a tremendous amount of hours. It's a tremendous amount of data. But when you think and you look at this and you say, well, what is my project? What do I need to do with this? How soon can I get a Revit model put together so I can start working with it? The beauty with these point clouds, you don't necessarily need your Revit model right away. Doesn't have to be Revit. It could be AutoCAD. But with something like this, you can take a slice out, crisp up the point cloud data, and then you can just start drafting, start working with your markers, working with your trace, get through all your schematic design while you've got a team that's going through all the existing conditions. Sometimes, too often, people get wrapped up in the need for that model before they even embark on schematic design. But even such as, elevations, those things, if you're only into CAD and say you're just doing historic window replacements, you don't need Revit for that. Other things such as terracotta element replacements, such as we had for the AT&T building, did not need Revit for that. You do need a pretty good modeling tool. I think Rhino is used exclusively for that, primarily, not exclusively. But then that was a terrific project to be a part of. Level of detail, very important thing in the professional office to consider, because it really gets into how deep in the weeds you're going to get with your existing conditions and everything else that you're going to put out. And, it seems that a lot of places that I find as I talk with folks and colleagues and the such is that they like that sweet spot right in there between 300 and 400. So it works really well with the general contractors and all the other necessary contractors on the site. They can do what they need to do. And it also just works without getting, again, too deep in the weeds, because as you keep working on the intensity of these models, it can really, it becomes time consuming very quick, and it just gets a little too fussy. Let's see, and I know we had a movie for this one, but I think we can move beyond that. What we can kind of get into, let's do that. Here's a lot of also too, this gets into a lot of the big use, you know, is things like clash detection, construction verification. Not everything is going to be, you know, historic preservation work with this technology. Sometimes it's just when you have an installation, say a boiler in an industrial building, you need to know where those pipes are. Is this boiler going to fit? You know, things of that nature. I've heard William tell that story at least half a dozen times now. I think it's a pretty good one. And I've actually been involved in a couple of projects where it was very similar to that. Industrial building, you have a big piece of equipment, and you need to know exactly what's going to get in the way of that. Just recently, I was gifted with a walk-in new building, and what I found really interesting and really appreciated, they had this terrific installation in the middle of it. And they had a few different options that they were looking at for it, because they had their art piece, and this is a massive thing. They had it scanned, each one of their little options. They brought those into their BIM model, the point cloud of those art installations, and then they were able to look at it and see how is it going to fit in the space. Is it going to fit in the space? Is it going to need a haircut? You know, any of these funny things. Because again, it was big thing. And, you know, hearing that they use the technology in such a way, you know, that really intrigued me, excited me thinking about it, because 7 years ago, when I walked into this, it wasn't as prevalent, and now it's becoming much more prevalent. I keep encouraging people as the technology becomes more easier to use, people are learning it. It's just a great tool. Now let's see. This guy. Oh, I don't think we're going to get it. Let's do this. We'll talk about this guy real quick. So, Unity Chapel, just down the road here. I was out there with Amanda Wagner, and we met with Ryan on Saturday morning. I think we were there for about 4 to 6 hours scanning this building. And just kind of talk real quickly about the process of this. As you saw in some of these other projects, you see the little globes, the little spheres. That was all the little points where the scanner was placed. And so for this building, we taped, you know, probably a couple dozen little targets on the outside of the building. And depending on the geometries, even the exterior can take quite a bit more time. It also depends on what is the level of clarity or resolution that you're trying to achieve. Are you going to do it in color? There's a lot of benefits to that. It doesn't need to be in color, but when you do put it in color, then you can utilize these things like the walkthroughs for fundraising efforts and things like that. All those walkthroughs become very important tools for stakeholders. But again, yeah, we were probably through this project quite a few times. Here's a snippet of the work that the students have produced with this project, and later, I think it's today, you'll be able to go through it, talk with the students, Ask them about their experience working with the scan data, processing it, things like that. But you know, even just with the point cloud, you know, alone, it's a great tool to kind of see, you know, what you can do with it, what you need to do with it, what are the issues. Sometimes with these buildings, we notice right away that a wall can be, you know, out quite a bit. You can see it with the naked eye, but once you get the scan data, now you've got something that you can quantify, and you can relay all that information to your engineers. And then here's just for some of the, because a lot of this it's all analysis. It's comparing data and things. Here's the HABS drawings from '95 for this building. I just want to kind of look at a real quick kind of overlay element of what the scan data is to the HABS drawings, you know, from back in '95, where they did not utilize this sort of technology. Oh, let's see. Let's do this. That's why it doesn't like me. Boo. But anyway, we'll go back to this. This is more fun. What I was able to notice and see with that data is that it really was, surprisingly, it was not off too much. Maybe just a few inches, you know, as it kind of got out. But then that gets into a little bit of what I was talking about earlier, in that, you know, depending on what your needs are, you know, you don't necessarily need, say, the level of precision of the FARO. Then you can look at things like the Matterport or some of these other hybrid tools that are out there and are available. Because with some certain, you know, building types, a couple of inches in your project is not going to be a big deal. Preservation projects, a lot of times, such as we see here, you know, all those details matter. They were put there, you know, with generally a great level of care. But then, as I see anyway, with a lot of these old buildings, the old building doesn't match the old drawings anyway. So, funny things. But then I think, oh, there's the movie. Nice. You know, I think with a lot of that, especially since missed on the couple of things I was going to point out with the HABS drawings, I think that essentially wraps it up and opens it up for any questions you might have for Vince or myself. And thank you.
Say, was your point with the Unity Chapel HABS drawing that scan caught some stuff, some as-built conditions that the drawings missed, or what was your conclusion going to be?
Let's see if I heard the question correctly. So, are we talking about the difference between the point cloud and the original HABS drawings, or what was the point behind it?
Oh, I was just curious to know what the big finish was going to be.
Oh, the big finish. Well, so that it wasn't that far off, because I've been, and I don't know if this is something, I think Vince may have even touched on this when he did the Pabst mansion, was it? I think that the dome on top, or it's another project that I'm also familiar with, in which case the nature of the dome is not what the actual geometry of it is. It's either, I think, a little more egg-shaped or a little more just bell or spherical shape. But what I like to do with these old drawings and then comparing with the point cloud data is, how does it line up? And one of the things I was especially curious about, I did have a slide, is that wonderful clock tower the bell tower. There's no clock. How well did they do on that? And they actually did, really quite well. with that bell tower, which I was really surprised. Just considering not knowing exactly what their methods were for measuring and all of that, it could have been a lot of trigonometry and some, you know, that sort of thing, with old engineering. But yeah, that was actually, I was really surprised at about how close it was. But and that's where it got into the matter of the level of the degree of accuracy between, like, FARO scanner degree of accuracy is, it's millimeters. It's like 0.01 millimeters within 10 feet, I think it is, or something like that. Whereas the Matterport, the degree of accuracy is 2 to 3 inches in 10 or 20 feet, something like that. So as it adds up, I mean, it really can add up. But, you know, again, it kind of comes down to, you know, what is your building type? Is it an old school that's all block masonry? You know what those geometries are, everything's fixed, it's very rigid, and so you can figure it out, you can massage it, you know, pretty good. Because the Matterport, you can get all of that work done in about a third of the time, it's very fast. However, it lacks that degree of accuracy.
Yep. Vince mentioned a 2-hour drone scan of a building. That is not as expensive as a 2-week program.
Yeah, no, not at all.
I have an example in Oshkosh, Merrill School, built in 1931, Art Deco, brick and stone, a lot of stuff, and the school board has decided to tear it down. And, they said they might scan it, but I don't think they have. But it's you know, the advantage of scan. We also have a set of original plans that they don't have. They throw it out, but. Whether there be an advantage to getting it scanned with like a drone thing, how much would something like that cost? Whether it's got additions on the back that are not historical, really, but the front
Sure.
3/4 of it would be an interesting. Maybe you could make a model or something.
Yeah, absolutely. I think in the world of preservation, it's a good point. You know, it's a lot of times a big question is where's the money going to come from? And for drone mobilization, you might not be capturing the level of geometry that you would get from a laser scan, but you get a snapshot in time in a high definition, photorealistic way of what it was. And so that might be enough, or enough to bite off. And so, you know, a drone mobilization like that is no more than a half day in the field. And so all the post-processing that would go into it, I think you're safely under, you know, a $5,000 budget on something like that. And, you know, maybe while you're out there, you're not scanning the entirety of it, but you can route your drone documentation in scale to take 1 to 2 scans, which doesn't drive up your scan time in the field all that much. So I think you could get a pretty robust preservation set for a facade like that, still in that half day, less than $5,000 budget. So, yep.
As a follow-up, I'm thinking of mitigation measures for buildings that are to be lost. And so the archivals, you know, needing a very full data set to record the building, because this is going to be our entire record of this building. How long-term stable are these files? How large are they? I always think about who's going to store them and the cost of perpetual storage.
Sure.
Where are we in that world right now of changing, you know, even the changing processing technology? Are you going to be able to open these files in 20 to 30 years?
If you go through the post-processing to get yourself to a point where you can simply export multiple files, that my answer would be absolutely yes. You will be able to open them. The reality is, and like Sean had mentioned, is, you know, 6-7 years ago, even opening point clouds inside Revit was a challenge. You do get an immense amount of data with it. So I think the goal would be to maintain, your highest density point cloud without any loss. And then you can export versions of it where you're doing point cloud decimation. And you can do a fair level of point cloud decimation that allows you to maintain the geometry and the understanding and the visual aspects that you would need working with the files. And you can get files under getting a 500 megabyte point cloud. You can break it up. Once you, again, did that point cloud processing, you can export a first floor and a second floor separately, but registered together so that when you're bringing them in, they're referenced to each other. So there's a number of ways in which you can organize the files. And the reality is it's a big part of doing this, as a professional company, is understanding the day-to-day use and the ease of use. So I would say, I guess coming back to your question, is generally yes, we are at a point where the file use is pretty comprehensively covered for low 500 megabyte for like a standard, even in the cell side theater, maybe even smaller than that for your day-to-day use, and then maybe 5 gigs for your untouched version, where you're maintaining all the colors and all the points without having decimated it. So, between those two point cloud exports, those will get you 20 years down the line and still be able to have both versions that are usable. So, yep. Awesome.
William Krieger.
My question, you want to make a drone scan of the
Yep.
school, who says a 3D model?
Yep.
Is that doable with the drone thing?
Yes, absolutely. Yep. The drone alone would be able to cover that. Yep.
Stuff like plans, original plans, do they scan those for, is there any reason to scan a plan to preserve it?
Yeah.
Yeah, absolutely. Getting things, in the digital format, scale plans, like we've done a couple digital resurrection projects where buildings that no longer exist, we use the original plans, digitize them, and then recreating kind of reverse engineering Revit models to show what once existed. And then getting into other programs like Rhino and other 3D mesh programs to get them as close to photorealistic as you can. So yeah, it's definitely always important to digitize the files because they can live in more places than just whoever possesses them in a basement somewhere. So yeah. Cool.
All right. Thanks, guys. So my name is William Kruger. I'm with the School of Architecture and Urban Planning. My passion is the Historic Preservation Institute. I'm blessed to work there, and my goal is to give the students skills that's going to get them a job. And then I can hit them up for money later when they're rich and famous. So this summer we went to Herstmannsue. This castle is owned by the Bader family. They donated its use to Queens College, and fortunately one of the Bader family had gone to school at the architecture school, and as an alum. They reached out to us because, well, basically we have probably the best suite of documentation equipment in the world, and I'm not exaggerating when I say that. So here's the students. Here we are in front of the castle. So we started here at UW-M, flew over to England, and it's a pretty cool castle. It's like one of the largest brick edifices in England. Very picturesque, beautiful. Queens College uses it as a campus. They require their students to go there for a full year of the various disciplines, but they don't have an architecture school. So here we are. A lot of good reasons to use LiDAR scanning. These guys all covered it, so I'll blow through a lot of these. But here's sort of a mirror image as if it were reflected in a pond of the castle and LiDAR data. So there's a lot of things you need to do when you're scanning. You sort of put a map together, show your scan locations, think ahead of time of how long it's going to take you. Line of sight, as these guys had mentioned, is really important. Here I am in one of the tunnels underneath, scanning some of the the bowels of the castle itself. Here's students putting up the targets. I put these tools in the hands of the students and make them do the work so they actually know how to do it. You can talk about stuff all you want, but until you actually use it, that's when you really get the understanding. And they're digesting the data. They're sitting down with the software. They're using the computers. They're producing the drawings. So here's this scan data taken into Revit, producing some drawings, analyzing them. There's just so much that you can do with this tool. It's very powerful. It's a great way to do analysis. Right now, we're just trying to archive this building and understand it. And then when you have the overlays, you can roll things around and try to experience them. And we can then take this into a VR environment if we wish. And you start noticing things, the additions, alterations, how much things are deflecting, how they've changed over time, slices through the building so you can see the inside to the outside. And then comparative data. Here's the scan data on one side and the staircase, a picture on the other. And then you have sets of data from hundreds of years ago to what we're doing right now. And you can look at those and see how things have changed over time, because things do change. And this is just a partial model of the castle with the data we have. We don't have a full set of data for the roofs yet and some of the chimneys, so they're not shown here. But you can start doing analysis and looking at, okay, what is the composition of this building? How is it put together? What are its individual parts? From simple things like the capstones on the bridge to working on the stone tracery and really getting an idea of what's going on there. So our files are good enough to send to a manufacturer so they can cut, reproduce pieces of stone tracery if they're needed. And even though this, we have a lot of technology to do this, it's a lot of work. And I didn't do it. My students did this. I give them the tools, I give them the software and the opportunity, and they love it. And then, now you start getting into marking things up. This needs to be looked at. Here's the individual parts. And you start to intuit, how is this wall built up? What is its individual makeup? And you don't know everything because you can't see inside, but you can start to understand where it's going. And then we do other things like simply walking around with a 360 camera. So you have another level of data. And there's precedents that we go to. We did not do this project, but this is what we're striving for. So you have Big Bend, and this is a full scan, and all the pieces are put together. This is the kind of thing we want to attain, but we're usually limited by time and how long the course works. And then there's other tools that are brought to bear. The Artec Leo, which Kendall Bruni was generous enough to get for us so we could use on this trip. It is a really excellent tool for reverse engineering decorative pieces. So here you have this wooden fireplace surround, and when you look at it closely, you'll see that there's a rosette missing here, but there's a good one over there. So if I scan the good one, I can create a new one and replace it. And then stone tracery. Again, with the Leo, all these different things are really simple or easy to do because we have a great technology, good computers, and honest to God, good students that really care and want to do a good job. And that is 50% of the battle right there, trying to develop an interest. And I seem to be pretty successful at that, and so is Matt. And students train the other students. So Tan, who has the yellow hat there, he was the first person I handed the Leo to, and he took off with it. So now he's showing the other students how to use it. Its use and the using of software. And then there's droning, and we've covered that a little bit, but out there at the castle, we had to, of course, get permission to drone. But there's all kinds of things that we were able to do and we were asked to do that we didn't plan on performing. It sort of goes through how that all works, but outside the castle was a field, and in this field is suspected location of the kilns that were used to make the bricks to make the castle. So the archaeologists are like, can you drone this? And I'm like, yeah, we can. Oh, because we need a topography map to sort of overlay on the magnetometry data we have, and we don't know how to do that. And it's like, well, that's cake. You know, we'll get our guys out there. They drone this, I think, in less than an hour, and then worked up the data, and then we were able to overlay that on there so they can start to do their interpretation. I'm not an archaeologist. I don't know how to look at that aspect, but I can give them the parts and pieces so they can do their job. So here's all the photos of that field. They're all put together. Now you have these different layers of data. And again, you can slice through and start seeing the topography. There's the happy archaeologist has their back turned to us with the red hair, and then the estate manager is just ecstatic about the extra service we were able to provide. And here's the magnetic data that we were able to overlay for them, because it was just, they don't have the skill set, they don't have the software. And for us, we're like, well, yeah, just give us the stuff, we'll scale it up, we'll put it in the same place, we're good to go. And while we're out there, it's like, oh, well, there's this folly way behind the castle. It's basically a garden shed for the guy that had the place. And it's really cool, but it's starting to fall apart. So we quickly captured it with drones. And we didn't draw any of this up, but we have it now archived so that in the future, we can work on this project. And again, here's all the different photos and the locations they were taken. You can sort of roll this around, get an idea of how it was done in space. And then you have the archive model, and from there you can slice through it. You have now elevations, and we're like, oh, there's this really neat home. And Mark Beagle was there visiting us, and he was staying at this Airbnb, and we looked at it, and we're like, hey, will you let us drone it? So 30 minutes, went out there, grabbed some data. Again, there's the shots. It wasn't real detailed, but it's enough to play with and get you excited. So that's what we do. And now we're also building an archive. All these projects in my professional career, since 2007, I've been laser scanning. So I have hundreds of things that I've scanned. I don't do that anymore. Now I just want to train people to do that. But all these projects are important, and I want to keep them. I don't want to lose them. And some of them are really interesting. Some of them are really dull. Regardless, I want that data. So we're trying to put it together in an archive. That too is another layer of work that we're working on. So this technology is really only limited by your imagination. I've done everything from caves to statues to Frito-Lay factories. I never say no, and just try to figure it out. And that's what I try to teach my students. That's all.
All right, so William pretty much covered everything we need to cover with the Artec Leo, but we'll go in a little bit more. I'm Amanda Wagner. I help run as an adjunct in HPI, and this is Emily Leahy, Andrea Mendoza, then we have Tanseral, Felipe Paez, and Nora Vogel. Vogel? Vogue, sorry. And so these are all the students who have worked with the Artec Leo. And so the topic is, how do we use the Artec Leo for historic preservation? So to go into what the Artec Leo is, it is a handheld device that uses AI-driven photogrammetry to create accurate 3D and detailed models, which allows for the creation of comprehensive point clouds. Before that, we had the Leo donated by Kendall. We're limited to other types of scanners, and these type of scanners were handheld laser scanners, or in later years we've used our phones to capture photogrammetry. But these used a lot of post-processing, and the quality wasn't great. Pretty much with the quality, you weren't really guaranteed an accurate or detailed model. All right, but here are some of the key features of the Artec Leo that we find are pretty cool and important. One, it has a touchscreen interface, which is really great. So while you are scanning, you can see your scan in real time. And so with it's really simple to use. You are pointing and shooting. While you are doing that and you see your scan in real time, it lets you know how much you've scanned. So it'll highlight green for when you have fully scanned an object, or it will turn red when you need to get more additional detail and information about whatever you are scanning. It will also let you know if you're scanning correctly, if you are going too fast, or you're too close or too far away from an object. So essentially, this thing is pretty foolproof that anyone can scan. All right. Also, it uses hybrid target-free tracking. So if you are familiar with laser scanners, so we've talked about, you do need a lot of targets to make sure when you have a bunch of scans, everything gets lined up and scanned together to make sure it all gets scanned together. With the Leo, you don't have to worry about setting up targets. It uses a hybrid target-free tracking system that pretty much allows it to be fused together then and there. And this makes it really versatile for many different environments. So you don't have to worry about if you're on scaffolding, setting up a bunch of targets or anything. You can scan while you are there. And because it also uses stable calibration, it ensures accuracy when you are scanning in a multitude of environments. It's also fully mobile. It's only 5.7 pounds, which after a while can feel, kind of heavy while you're holding it and scanning it. But luckily here, Tan is really strong, so he can scan for a long period of time. And the other thing it's really convenient too is that it is fully mobile and wireless. So when you are scanning, you do not need a computer on site. You only need a computer later on for post-processing. All right. And here are some of the important specs of the Leo. One of the coolest parts is that it has an accuracy of up to 0.1 millimeters or 0.004 inches. So the accuracy is incredible for the amount of detail that it can grab. Also, it is extremely fast, as if you are familiar with frames per second, and it supports a multitude of output formats, making it compatible with various 3D modeling and design software. All right, so HPI and Leo. William went over a lot of this. So pretty much, what do we use the Leo for? We use it for scanning architectural artifacts, architectural elements, pretty much anything that you can think of that needs some really good detailed scanning. It is especially useful in preserving fragile or inaccessible items without causing them any damage. So we're not moving things around, we're not taking things off of buildings. We can scan it then and there, so you don't have to worry about it breaking. All right, and so we're also talking about the first time we really used it was in Hermannsø, and it is pretty much, we used this for about our first time scanning over this summer. So we are able to scan many historic artifacts and objects within the castle, such as the fireplaces, doors, windows, staircases, just about everything that we can get our hands on. And as you can see, this is the type of detail that comes out when you are scanning with the model or scanning with the Leo. And we are able to replicate all of these details. For example, we are able to replicate it in a small 3D print, but this saves all of this information. So if there's ever any future damage to this door, we have an accurate model that we can literally recreate the pieces through like CNCing, 3D printing, whatever you think, pretty much anything that you can imagine. And then here are just some more examples of how we took this window here, created a 3D model, and then one of our students was able to take this 3D model, bring it into Revit, if you're familiar with the BIM modeling program, and recreate it as she was working on the Revit model for the castle. So now we're going to do a Leo demonstration. So Tan here is going to go right ahead and show you how it is done.
Should be. It's good.
I don't think you guys can see it, but first we need to set the brightness and the distances and then all the variables for the scan. And like if we want the texture or if we want the base to be removed, we need to set those beforehand, or we can remove it during the post-processing. And I'm just going to skip.
Just yell.
What?
Keep that one on. Oh, how'd that happen? Cool.
Okay, so now this is the result of processing. This can take approximately 1 hour to produce in a medium resolution. And the scanning in general it's very short, just some minutes.
So to go into more depth about the post-processing structure of using the Artec Leo, there's 3 simple steps in a way. So there's scan object, clean it, and export it. It sounds really easy, and it kind of is when you get to doing it a lot. So in this example, I'm just going to be going through the process of using the Venus rising from the sea. This is also inspired by Kendall. So we actually went out, scanned this object this summer, and then we went through the process of cleaning it. So the steps within cleaning it are edit, align, register, simplify the mesh, and then texturize. So starting out cleaning it, this is what it looked like right when we put it in the program itself. We use Artec Studio. It works with the Leo, it's very compatible. And then we went in and we edited. So as you can see in the bottom right corner, there's a bit of editing, and you can do this like very similar to other products using like lasso tools and that type of editing software. And then from there, we aligned the scans themselves. And so in this, I don't know what's going on, sorry. But we used multiple scans, and we were able to align them together. Then from there, it registered all those points, because realistically, these are just a bunch of points that you're trying to align and connect. And through these programs and through these types of technology that are continuing to evolve, we're able to create some simplified meshes from there. So as you can see, hopefully, a lot of those pieces that were maybe broken or maybe had some holes in them, we're able to actually completely close and make a watertight mesh. And then it kind of goes back within those meshes, and it finds where there's lack of texture, and it finds where there's holes, and it completely creates a processed comprehensive model. So that's the post-process of here, and so this creates an exportable file that we can use. Sorry for the flickering, but. And so like we did this morning, we were able to scan. This is William. We were able to scan and we were able to process. So that was just this morning. So we scanned around probably 9 a.m. William, and we were able to process him and put him into this PowerPoint. And we'll have him printed later. To go back to Venus rising from the sea, just showing this is the way that we're able to 3D print it. It creates these trees that act as supports for the model. So obviously, it can't just print a box. It has to create levels of support. And then we physically print them, so we actually have them in the drafting room. When we go in there, you can actually pick it up, super durable. I wouldn't recommend dropping it, but if you do, it's okay. Then we can also digitally restore. So we work a lot with terracotta, and we work a lot with broken terracotta and being able to restore it through softwares like Rhino and Blender. We're able to create these watertight meshes from the Leo scans and actually combine the terracotta back to its original condition. And then we also can do shop drawings. So this is probably a super common way of seeing architecture for most of you. And this is what we scanned when we were in Italy this summer.
Okay, now we are going to make a comparison between two of our technologies, which is the Artec Leo and the FARO.
You got it.
We are going to compare it on several characteristics. One of them being the price.
Maybe
So
push it in all the way.
the Artec cost $35,000, and the FARO costs 3 times more, 3 or 4 times more. The second element is the software. The software for the FARO is 2 or 3 times more expensive, and it comes to, well, and when you acquire the Artec, the software comes with it if you acquire the full package, which is very comfortable. Another advantage when it comes to the software is that FARO requires technical knowledge to be processed, to be aligned, to be worked with. Artec doesn't. It's very intuitive, very quick, and is easier on the computer, which means it's easier for the computer to process it. The next element that we should think of is the time that it takes to scan. So Artec can achieve 1/28 of an inch, and the FARO cannot do it. But when you use the higher quality, it takes a lot of time. In the time that you would scan with the FARO, you already have scanned with the Artec and processed it and maybe even printed it. So it's very fast. Now, what's the advantage with the FARO? That it can scan huge elements. So this is Teotihuacan in Mexico, and this is one of the biggest. This is one of the biggest pieces scanned with FARO. This is a full complex, and it was scanned by FARO. On the other hand, the biggest piece scanned with an Artec Leo is Boeing 747. Now, what's the technical comparison? When you are doing processing and fixing on digital pieces, we are talking about how healthy the mesh is. And Artec produces very healthy pieces, very easy to modify, very easy to fix digitally. And also, they can be friends. So you can take the pieces that you scan with the Artec and put them in the FARO software and produce very detailed elements. Both of them have cameras that are similar to a GoPro, so they have a very good color, and you can this is not only for architecture. This can be used to make movies, to make backgrounds, to make art, and it makes the fabrication drawings considerably faster, very accurate. A piece like this, between the moment that we scan it to the moment that we process it to this result that you're seeing here, we can do it in around 6 hours on a good day.
What's a bad day?
7.
We don't talk about bad days.
So this is some of the things that we have scanned with the Artec. I think that's it. Do you have any questions? Yes, it's handheld.
That's 35,000.
Yes, and the FARO is stationary, and the FARO also requires a tripod, so it's harder to carry around. Yes.
Good stuff. I see the Schlitz up there, huh?
There's a question
We
up
did that
there
the other
too.
day. There was a
Fly the
question.
FARO with a drone?
Sorry, what?
Is the FARO flown with a drone?
So there are so there are specific drones that use the same technology, but FARO doesn't have them on a good standpoint.
FARO produces various scanning products. The FARO that he's referring to is called the Scan Arm, and it is sits on a tripod. Then we had the FARO that Vince and I both use, and there's a whole host of products. So when we say FARO, we're trying to compare apples to apples if we can. And with what we were doing with the Leo, that is compared to the FARO Scan Arm, which you've not seen an image of. It's not here. So yeah, it's.
Is there a drone with the Leo technology though?
So there's LiDAR drones, and LiDAR is what Leo uses. Obviously, like drones, you can't be on the drone when you're scanning those, so you can't see it like when it's going, but there's a lot of evolving softwares and a lot of evolving technologies that these things that we can just imagine in the moment are actually viable things, just super expensive.
Actually, I think Emily is spearheading another question there about the drone guys in Illinois.
Yeah.
Right, that you've been talking to about getting a more advanced kind of scanner device, which is kind of at the heart of your question, from a drone.
Yeah, so we're hopefully going to be able, by the end of the school year, to have a drone that does LiDAR scanning, ground penetrating radar, thermal detecting, and photogrammetry.
Each feature is a different package on the drone, and you swap it out.
Yeah, so basically it's like a head, like that you can just kind of take out like a battery that you can just kind of keep inputting on the drone, and it flies at different, like, I guess, in different ways, just depending on how heavy it is. Oh, sorry.
Well, and I guess the trick is that you can program the drone to get the exact grid that you want.
Yeah, exactly. So there's actually a lot of flight tracking things that drones are now doing, and DJI is a very common drone manufacturer, and that specifically one has like a waypoint feature. So you can actually plan your flies out before you even go on site, which has been really helpful. And you can also do that to capture the whole thing more effectively versus going there and trying to figure it out. But even going there and trying to figure it out, you can kind of do a whole grid system as well.
There was a question, I think, all the way up, right? Yeah.
Yeah, the handheld that you were just using, about how far away how far away can you be from your object?
So you can scan 1.8 meters, so around 6 feet. But to get a nice color, like texture, it should be like 3 feet, I can say.
So you can get the feel of what the Institute is all about. We haven't invented any of this stuff. This is all stuff on the market. We're putting it together in the pursuit of historic preservation, saving great buildings, great pieces of art, and so forth, and making it usable, making it reasonable. Some of these components are very expensive at this point, but it seems to me each year, William, those prices go down all the time. And so the pieces are there, and the Institute just is an entity that kind of brings those things together, again, in pursuit of historic preservation and perhaps saving some of Wisconsin's great sacred places.